Welcome to solverfy.
This is the answer to Chapter 15, problem number 73 from the Smith Organic Chemistry textbook. And this problem asks us to explain why polystyrene is much more readily oxidized by oxygen in the air than polyethylene is, and which H's in polystyrene are most easily abstracted and why. Okay, and so I've drawn a single monomer in a polymer chain of polystyrene here. So I've drawn a single styrene subunit, and I've drawn in the hydrogen that's most easily abstracted. And the reason that it's most easily abstracted is because it's a benzylic hydrogen. So it's on a carbon that is directly attached to an aromatic ring. And so we call that position benzylic. And because of the resonance structures that are possible around the aromatic ring, this position is much more stable than we might expect for just a carbon. And so when we do abstract that hydrogen, we get this structure. So this structure here with the radical on that benzylic carbon. And so we can draw several resonance structures for this based on moving that radical around the ring. So our first resonance structure is going to put a double bond here. And the free radical here. Our next resonance structure just moves the unpaired electron around the ring, basically. And so for each of these, we can just move where that unpaired electron is and move a double bond along with it. Okay, and then we have one more resonance structure where we're sort of back to where we've started, but the double bonds are all shifted around in the ring. So our last resonance structure looks like this. So we're back to the three double bonds in the ring, but they've been moved around. So this is technically a different structure than the first one. So we have these 5 resonance structures that are possible for this benzylic radical. And so that's going to impart a pretty large degree of stability to that radical. And obviously, if it's more stable, it's more easily formed. And then if we look at polyethylene, so a polyethylene chain, remember, is just something like this. So there's no functionality here. There's certainly no aromatic rings here. And so if we just abstract one of these hydrogens, we get a radical on a carbon, and there's no resonance structures that we can draw here. And so that's going to be a much less stable radical, and therefore much harder to form. And so that's why polystyrene is much more easily oxidized in air than polyethylene. And again, the hydrogen that I've drawn in this very first structure to the left is the most easily abstracted hydrogen, and that's because it is a benzylic hydrogen. And that's the answer to Chapter 15, problem number 73.